Hi, good morning. We are Team Lights Camera, and we are from the School of Science and Technology. So, uh, so a brief introduction of our team members will be Ryan Ze, right, Elliot Koh, and Ong Zhishen. So, our initial problem statement was that the visually impaired need an aid device to assist them in identifying the capacity of a power bank based on the lights, because the lights cannot be physically touched or felt. Because currently most power banks indicate power level with an LED indicator, visually impaired people may find it difficult to operate such a power bank because they are unable to identify the power level of the power bank. So, for example, a power bank that might have four lights to indicate a battery at 25%, 50%, 75%, 100%. Someone with visual impairment will be unable to tell how much battery is actually left in a power bank because they are not able to see the lights. So as a result, these people may find it difficult or inconvenient to recharge their devices outside of their house, or when they are unable to find someone else to help them do it, or any other methods they might do it normally. So our community partner that we worked with was the Singapore Association of the Visually Handicapped, or the SAVH. So to address this problem that the visually impaired people are facing, they provide us with this problem statement, and to aid us in the design and problem solving process in general. Hong Sung, which was the representative for SASVH, has provided us with some various important information and viewpoints that we had to keep in mind while planning and designing the prototype. So, uh, so currently, our group decided to approach the problem by converting the information displayed by the LED lights onto the power bank into another form so it can be received by visually impaired people. To do so, we wanted to create a prototype that was capable of converting LED lights into sound by creating a device that captures pictures and uses a machine learning algorithm to identify the number of LEDs lighted on a power bank. So what this means is basically this prototype will technically act as like a pair of eyes to help to look at a power bank, and therefore output the number or the battery percentage of a power bank via sound. And this device will then describe to the user number of LEDs on through a sound input.
Before we are able to test version 1 of our idea, we had to construct the physical prototype. This included a camera, and our group had to experiment with the positioning of the camera to see which position would be the most convenient for the user and how easily it is for the user to aim the device at the power bank they are holding on their hand. We then decided to place the camera on a headgear that could be worn by the user, such as at the side of the glasses. But after much testing, we received feedback from our community partner and decided to modify our idea, as the feedback provided was that our device may let the user stand out a lot in the public scenario, and that is not good for the user. Besides, although it may be easy for us to look in the right direction, it may be hard for the disabled to do so. Hence, we created version 2 of our solution, which turns the headgear into an app. However, the working principle of detecting the number of lights on the power bank remains the same. The decision was also made when we realized that there were also existing apps that provided services to the visually impaired people. Last but not least, the idea of the prototype being an app also makes it less complicated for the user to use, as the user will not have to fiddle with the hardware, which may be hard for the user to adapt to. Some of the benefits of our prototype includes the visually impaired people having better access to a source to charge their devices, as that they will be able to gauge whether their power bank is low on battery, needs charging, or is functional as it is fully charged, making their lives more convenient. Due to the complexity of some of our proposed features, we are unable to create and develop all the features with our limited time and skill set. Below include some of the features that we plan to implement in the future to improve the functionality and usability of our solution. So for voice output, we can use it to notify visually impaired people about the power bank status. And identify whether lights are present to see if to notify the disabled people whether they are aiming the app, like their phone, correctly at the power bank and see whether the power bank is being detected by the camera. Make the app UI more friendly so that it's accessible to a wider range of audience. And last but not least, integrate other app features for visually impaired people to make their experience more convenient. This will make our service that we have provided fuller and more convenient for our target user. Thank you.
Will now be open for questions.
Thank you, Team LightsCamera, for the presentation. Maybe I can start off by asking you guys what were your biggest takeaways from working on this project? Because I think it was like a whole process of like a few months. Maybe you can share with us what your biggest takeaways were.
So I think in general, our biggest takeaway was really developing an appreciation of how those with visually impaired actually navigate about their lives, and getting to, in a way, experience or at least try and empathize with them, and know the difficulty that comes about because we live in a very visual world, and really trying to test the prototype and without and trying to empathize with someone who is visually impaired and not able to interact with this visual world. It really was an eye-opener for us to actually see how difficult it was.
It was also a fulfilling experience for us as we were able to use the skill sets, like some of the programming knowledge that we have learned in school, and use it to solve some of the problems that we have empathized with sympathize with the disabled people.
Maybe as a follow-up question, do any of you personally know any visually impaired people? Is that why you embarked on this, or was it just something that you observed in Singapore? That's why you decided to come up with this solution.
Actually, we embarked on this project. I think it will be more of like a technical standpoint. We were also relatively interested in similar fields of using computer vision and general machine learning in general. So we thought maybe we could apply our skills in this area.
Oh, okay. Thank you for sharing. Maybe you guys want to explain a bit behind the reason behind your team name, like LightsCamera. Is there any particular reason for you naming your team that?
So we actually named it LightsCamera is because we felt I think we took it in a very literal sense. So we felt like, okay, we're trying to use a camera to sense light on a power bank. So why not LightsCamera? So I think we just took it very literally. So yeah.
Okay, thank you for sharing. Yeah, okay, that's all the time we have for now. So thank you for your presentation and for answering our questions. Next up, we have Photo Receptor, who have developed a color scanner ring for the visually impaired and have presented another way to read light indicators. So, Photo Receptor, the stage is all yours.
Testing. All right. So, good afternoon. We are Team Photo Receptor, made of me, Clive, Saruk, and Elgin. We are students from mechanical engineering in NTU, and we decided to work on the challenge statement where visually impaired people have faced difficulties looking at the capacity of their power banks, especially for those power banks that just use indicator lights to show 25%, 50%, 75%, this kind of things. So we created a prototype called Photo Receptor. Photo Receptor is made of a banger which houses various electric components. These include the light sensor, vibrator, and microprocessor. The microprocessor here used is a Arduino, but we've done our research smaller processors can be used too. For example, there's another model in the market called a Tiny Lily, which my group mate Saurabh has been working on, and it seems like it can work. As you can see, the bangle holds all the equipment. It will be covered with a hole for the light sensor to see outside. Yes, so this shows this is what photoreceptor is with all the components housed inside. Please give me a moment. Is it escape? How do I go back? Apologies. Okay. Is the MC there?
Oh,
Can't
okay.
see.
We'll help you. We'll take over and help you. You can go ahead with your presentation.
Okay, thanks. The reason a bangle is used is to make the movement of using photoreceptor more natural. This is so as to not draw unnecessary attention to users. This video here is supposed to show me giving an example of using it, but due to the technical error just now, I think I won't play it. The movement, as you can see from the picture over there, is supposed to be as natural as possible. Photoreceptor can let the user know what it sees, whether there's light, and if it's red, yellow, or green. The basic signal colors, you can say yes. Users can customize how they want photoreceptor to feedback. It's just a matter of uploading new code. We've actually received feedback after testing out that instead of a more efficient way for photoreceptor to feedback to users, so we can implement it for future usage. Yes, and for future developments, we aim to improve the material of photoreceptor to be more comfortable and in line with other wrist-worn devices. For example, watches or fitness trackers provided by Health Promotion Board. We are also evaluating the use of Lipo batteries. These are rechargeable and have a longer life. However, to compare right now, we are using button batteries inside photoreceptor, which can't really last long also. Adopting Lipo batteries, however, require additional rewiring of the circuit. So if all goes well, the bangle should be able to be customized to fit its user's fashion. But this is a minor point, I feel. We have also given photoreceptor for feedback. Admittedly, it is not ready to be released to the market yet. Our trial user has suggested that we make photoreceptor adjustable to different wrist sizes, improve the color sensitivity, be able to sense flashing lights too, something we have not thought of, quite interesting, and to be able to easily locate where the color sensor is for easy usage. So yes, with that, I end my presentation. I'd like to thank Ms. Elda, our mentor, Mr. Liner, who gave us his feedback, and Mr. Akmal for helping us to set up the prototype. Yes, there's supposed to be a big question mark over here. Is there any questions?
Okay, thank you for your presentation. Maybe one question I had was, what was your biggest challenge in creating this prototype? And yeah, maybe you can share with us like how you guys overcame these challenges.
Our biggest challenge is
So one thing that we definitely faced along the way was how to fit everything, because the device that we're planning to build, right, it has to encompass a lot of things. It doesn't just have to detect red, green, and blue. It has to account for different kinds of signal that come out of power bank. Secondly, it has to account for different kind of lighting conditions, So if, let's say, someone is trying to test a power bank in sunlight versus in indoor lighting or no lighting at all, these kind of different lighting sources, they confuse the sensitivity of the color sensor itself. So for that, we had to kind of constrict the opening of the color sensor that let in the light to the bangle. So that was one way we tried to overcome it. And as with any other product development, it also introduced some other problems that because of the small opening, the aperture, we had to place the bangle more closer to the power bank. Then that was one thing that we in the future are going to work on the design more. And some other things were obviously fitting everything in a small space is a challenge. Right now, we're working with the bangle. In the future, as Clyde mentioned, we are working with smaller processors, and we hope to move from a bangle to a small ring. That's even more inconspicuous and more useful for our brand users.
Thank you for sharing. I think the ring sounds like a very good idea. Maybe you could also share about what the most rewarding thing about this whole development of this product was for your whole team.
Yeah, definitely. It goes without saying. I can say it on the behalf of both my teammates. It's for some good in the world. So that's the very rewarding aspect already. And speaking from a personal standpoint, I've grown in a community where my childhood best friend, whose house I grew up in half of the time, his brother was partially blind. So I kind of saw that kind of a life from a very young age. My mother used to take me to volunteering centers from a very young age. So I see how blessed I personally am just to be blessed with everything that's all right with my body, and being able to use the education that I'm getting from the university. And I can say, I'm sure my teammates feel the same, being able to use that to really benefit these other members of the community and uplifting them to the same equity that we face in our life. It's already enough, fulfilling enough for us.
Thank you for sharing, and thank you for your whole team for doing your presentation. That's all the time we have now.